All right, hello pre-cal. This is lesson 6.7, signs of trig ratios. We want to know what quadrant an angle might lie in, given certain conditions. And we have what seems like something we've already done, and it is. It's a lot of review. And so this is kind of an excellent way to end in that you have one little thing we're going to talk about, and then everything else is stuff you've already been doing. And it's a review of basically this whole unit. Which means test very, very soon. So hopefully this all makes sense. We're going to start with our XY coordinate plane because we put our unit circle on top of the coordinate plane. And so everything that we ask is basically based on ordered pairs. And so in quadrant 1, we know that all of the ordered pairs are positive x values and positive y values. We know that in quadrant 2, all the ordered pairs are negative x values. Oh, I don't want to write negative x. Negative values in the x direction and positive values in the y direction. Down here in quadrant 3, we know the signs are negative, negative. And in quadrant 4, positive x values, negative y values. So because the unit circle is really based on all these coordinates in the coordinate plane, we also know that the cosine ratio is the same as the x coordinate, and the sine ratio is the same as the y coordinate. So we can say that if I know that the cosine of some angle is greater than 0, which means it's positive, then I could say that it's part of quadrant 1. It must be in quadrant 1. Or, again, cosine sine, it could be in quadrant 4. Because cosine is positive in quadrants 1 and 4. So I also know, for instance, here, I know that the sine of whatever angle is greater than 0. So meaning the sine greater than 0 means positive, right? So once again, I could say, oh, if I know that the sine of some angle is positive, is greater than 0, then it must be in quadrant 1. Almost. It actually could be in quadrant 1 or quadrant 2. All right. What about tangent? What is the tangent in quadrant 1? Well, how do we find tangent? Remember, tangent is the y-coordinate over the x-coordinate. So that's going to be positive divided by positive, which would still be greater than 0. Interesting. So it looks like in quadrant 1, cosine is positive, sine is positive, and tangent is positive. And so it turns out that in quadrant 1, all trig functions are greater than 0. All 6, in fact, are greater than 0. All are positive. Okay. So why is secant still positive? Imagine if we knew that the value was positive a half, let's say. All right. So we knew that we had that x coordinate was a half. The secant would just be the reciprocal of this, and that would just flip the 1/2 and it'd become a 2. Did it change the sign? No. So it turns out that regardless if we're given the basic 3 or the other reciprocal functions, they're the same. That's kind of interesting. So in quadrant 1, all the trig functions are positive. All the trig functions are positive. What about quadrant 2? Again, when we look at quadrant 2, looks like cosine. Cosine of some angle is less than 0. That's the one that's negative. Sine is positive. Sine would be greater than 0. What's tangent? Tangent would be y over x. Positive divided by negative would be a negative result. So in quadrant 2, sine is positive And cosine and tangent are negative. And so secant would also be negative, and cotangent would also be negative, and cosecant would turn out to be positive. So in quadrant 2, sine is positive. Sine is positive, also cosecant, all right? So sine is positive. Let's see, in quadrant 3, again, cosine, sine. So in quadrant 3, cosine of some angle is less than 0. Sine of some angle is less than 0. What would tangent be? And consequently, cotangent. Y over x, negative divided by negative, would give us a positive result. So tangent ends up being the positive one. And sine and cosine are both negative in quadrant 3. So it turns out in quadrant 3, tangent is positive. And there's a reason I'm doing this. Let's look at quadrant 4. Cosine, sine. Cosine of some angle is greater than 0. Sine of some angle would be less than 0. What's tangent? Tangent is y over x. Negative divided by positive is a negative result. So it looks like cosine is positive, but these others are negative. So in quadrant 4, cosine is positive. All right. Well, that was a whole lot of effort for me to finally tell you that, hey, there's a little thing that I've never taught before, but I always think about teaching. ASTC. ASTC. All students take calculus. All students take calculus. All are positive. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. Cosine is positive in quadrant 4. All students take calculus is the little mnemonic device to help you remember that in quadrant 1, all of them are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. And maybe that's helpful for you. I don't actually like it because I think in terms of half planes. So when I look at this, cosine is positive in quadrants 1 and 4. Sine is positive in quadrants 1 and 2. Sine is negative in quadrants 3 and 4. Tangent is positive going uphill. Tangent is negative going downhill. Cosine is negative in 2 and 3. So that's what I think about. That's how I'm going to do it because I don't know. That's just how I think. But maybe the mnemonic is helpful for you. But I like to just draw this picture and use a little bit of elimination. So let's see how that works. Here's what you're going to see today. In which quadrant does theta lie given the following conditions? All right. So they're telling me that cosine is less than 0. So cosine is negative. And cosecant is greater than 0. Now cosecant takes the same positive or negative. Cosecant is the reciprocal of sine. So I'm just going to automatically convert that and say I don't really care about cosecant. He's got the same sign as sine. All right. And he turns out to be positive. So what I'm going to do is just make a little picture. And I know that cosine is negative. Cosine are the x values, and x values are negative in quadrants 2 and 3. So that's here and here. And sine is positive. Those are y values. Y values are positive up here in quadrants 1 and 2. 1 and 2. So which quadrant works for both? There's only one winner, and it's a clear winner. So theta, whoops, that's a Q. Theta lies in quadrant 2. See how I did that? What works for both? That's how I do things. All right, let's try again. Quadrant 1, 2, 3, 4. Okay. This says tangent is less than 0. So where is tangent negative? Tangent is negative going downhill. So that's quadrants 2 or 4. So I put little check marks in there. Okay. Where is secant? I don't care about secant. Secant is the reciprocal of cosine. So where is cosine positive? Cosine are the y values. Not y, my mistake. Cosine are the x values. X's are positive over here. So that's quadrants 1 and 4. So check mark in 1, check mark in 4. Which one works for both? Theta in quadrant 4. That's it. So very little work here if you can think it through. You don't have to draw the picture. You can just write stuff. They both have a 4, so that works. Here they both have a 2. Yay! All right. But you'll notice how there's 2 answers for each, right? So cosine is negative in 2 and 3. So there's always 2 quadrants where that's true. All right. Example 2. So this is stuff you've done before, and so it's kind of like a review. So I'm just going to do these real fast. If theta is an angle in standard position and its terminal side passes through the point -3, -7. So I can draw that. Theta is an angle in standard position and passes through the point -3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Right there is -3, -7. So my angle in standard position starts here. Whoops. Missed. What? Oh, it's a sliding point. Look at that. Magic. All right. So here is angle theta. Theta, not Q. All right. Oh, God. Theta. There we go. There's our angle theta. And so it looks like it's terminating in quadrant 3, which is wonderful. So, of course, we're going to convert it into a triangle. So we create our little reference triangle, theta prime. And we can label it. So that would be 3 units to the left and 7 units down. So -3 and a -7. What do we need to do? Oh, yeah, you remember, find the third side. We do this all the time. Like, this never goes away. So we have -3 squared plus -7 squared equals the radius squared. That's 9 plus 49, which is 58. And when we take a square root, 58, I think 58, I don't think it's prime. Oh, it's not prime, of course. It's divisible by 2. Yeah, okay. Radical 58, 2 times 29. So I just had to do that. 29 is prime, and 2 is prime, so there's no squares that can come out. So this radius is square root of 58. Now that we've completed the triangle, now we can figure out the value of secant according to theta prime. Secant would be hypotenuse over adjacent, the reciprocal of cosine. Hypotenuse is radical 58, and the adjacent side, opposite is -7, adjacent would be -3. So that's a good answer. All right, over here, given cosine of some angle is 7/53, and that angle is in quadrant 4. It's good information. So remember, anytime they give me a trig equation, there's a related triangle that I can draw, and we're going to draw it in quadrant 4. So we've got some angle, standard position, opening up and ending in quadrant 4. So here's our angle A. And I'm going to go ahead and pick a point, any point, and drop an altitude to the x-axis. That makes our reference angle a prime. Now, this was cosine, and the cosine ratio is adjacent over hypotenuse. So adjacent here would be this side of 7, and the hypotenuse is radical 53. So we need to figure out this third side. It's going vertical, so I'm going to call it y. So to find the third side, I have 7 squared plus y squared equals the square root of 53 squared. 49 plus y squared equals 53. Move the 49 over. That's 4. And then, so we get y equals plus or minus 2. When you take a square root, don't forget the plus or minus. What do we need? Negative, correct. It should be negative because we're here going down to get to this point on the terminal side. So always draw those triangles. So cosecant of our angle, of our little reference angle there, cosecant would be hypotenuse over opposite, the reciprocal of sine. So the hypotenuse is radical 53, and the opposite side, opposite would be -2. There we go. Ladies and gentlemen, that's it. So it's a really good review assignment, and hopefully it'll go really smoothly. But again, if you have problems, please see me in office hours, stay after class, come talk to me. Have a good day.